Welcome to the project demonstration of hybrid power generation using solar, wind and piezo. So the output from these three sources is given as input to the 12 volt 3 amp battery pack we are using through the individual charging circuits. So here we have connected the wind power generation source to the parallelly charging circuits, and again parallelly is given as input to the wind voltage sensor here, and same thing for the solar panel also, and again the piezo plus directly given as input to the microcontroller at A2 pin. So here we have interfaced the microcontroller inputs to the wind and solar and piezo plates at A0, A1, A2 pins, and parallelly the same output is from these three sources given as voltage source input to the 12 3 amps battery circuits through these charging circuits. And also we are using the grid connection to charge a battery whenever these three sources unable to provide the sufficient voltage to charge a battery. So that grid is from this transformer, so 230 volts AC input to this transformer, so which will step down the 230 volts AC to 12 volts of AC. So that 12 volts AC input to the charging circuits. So here we can see the three charging circuits look alike same. So each charging circuit consists of rectifier section and filter section and to the unidirectional current flow purpose diodes. So here when we are providing 12 volts AC from this transformer, these four diodes will act as a rectifier to convert the AC to pulsating DC, and this capacitor will make it as smooth if is there any ripples are generated after the rectification, so that will be neutralized by this capacitor, and through these two diodes we are providing that voltage to the 12 volt 3 amp battery. So here when we are providing AC input, these diodes will act as a rectifier to convert AC to DC, but we are providing DC power supply from this generator, solar panel and piezo also. So there also we are using the four diodes. So here the purpose of the diodes is polarity correctors. If the wind turbine rotates in clockwise or counterclockwise, so the polarity will varies from this output of the generator. So in order to rectify that to plus, minus to minus, we are using these four diodes as a polarity correctors. Means when we are providing AC inputs, these four diodes will act as a rectifier, and when we are using the DC input, these four diodes will act as a polarity correctors to make it output as a plus, minus directly, so that we can protect the battery while charging. So in the capacitor and diode surface unidirectional current flow purpose, whenever the battery is fully charged, so these extra two diodes will act as a unidirectional current flow, means they are block the current flow from the battery to the sources, so that we can protect the source and the charging circuit directly. So right, so coming to this battery, there we can see the 6 batteries pack. In that 3 batteries are connected in parallel, series, and these 3 battery packs are in parallel. So that 12 volt 1 amp, 12 volt 1 amp and 12 volt 1 amp. So we'll get a 12 volt 3 amps directly output from this battery pack, and that is the input to the inverter circuits. So on this inverter circuit we can see one IC which can generate 50 hertz of clock frequency. That is the input to the 2 MOSFETs. So the MOSFET output is 12 volts AC of 3 amps, and that is the input to this step up transformer, so which will step up the 12 volts AC of 3 amps to 230 volts AC step up. So that is the input to our AC load as well as 3-pin socket. So here we can connect any load whichever we want, which should be less than the 250 watts of load. So coming to the ratings, so here we are using 12 volts 20 watts wind turbine and 12 volts 10 watts of piezo and 12 volts 20 watts of this solar panel. So this is the main ratings for the generating circuits, and parallelly as we discussed initially that is given as input to the microcontroller at A0, A1, A2 pins. So the voltage will be measured by this microcontroller, and that will be displayed continuously on this 16:2 LCD screen, which we have interfaced at the pin number B2 to pin number B7. So here the overall circuit operating voltage is 12 volts is the input, but coming to the microcontroller it needs 5 volts as operating voltage. For that purpose we are going to use 7805 regulator over here. So we can see this black color one is the 7805 regulator, so which will take above 5 volts and provide us the constant DC 5 volts output, so which is the main operating voltage to our circuit. So when we switch on the power supply to the whole circuit, so this is the main on off switch to make the circuit run, and this is the on off switch for the inverter, and this is the on off switch to control this load. So from this one directly we can provide the power supply to this 3-pin sockets. So let us see the demonstration. So on the kit, welcome message displayed, and after that the voltages coming from the sources will be displayed on the LCD screen. So as of now wind is not rotating. So when I am rotating the wind, right, so you can see the wind voltage is generated over here for this speed, and solar already we placed under the tube lighting, that's why it's providing some voltage. And coming to the piezo, so when we are applying the force on this piezo plate, so you can see the voltage increasing from the piezo plate section. And coming to the solar panel also, just place any sunlight on that one. So when we place this under the sunlight, so we'll get the maximum of 18 volts, and after the charging circuit it will be regulated to the 12 volts, so the battery will get fully charged from that power source. And the next, coming to the load, so inverter got switched on. Right, so inverter on of the load. So already the 3-pin socket getting power supply. So just by placing the heater, so we can run that. So as you can see that the heater got switched on, that's why the bulb is getting low voltage as it's consuming the more power. You can switch off that. So when we disconnect that, we can observe the brightness of the light is increasing. As you can see the heater got power supply and it's got heat up. So we can use this for water heating in cool areas, for solar purpose also. So the whole system getting power supply from the two renewable sources like solar and wind, and one is a non-renewable source from this piezo plates. So these are 3 main input sources to that, and safe purpose we are using the 230 volts grid power supply also. So that is a rechargeable section. Whenever there is no sufficient power supply from the sources, we can charge a battery from this 230 volts AC inputs directly. So here we are using the inverter of 12 volts DC power supply to 230 volts AC, and it can handle up to 250 watts of load. So when we are on this heater, so it's a 250 watts heater, so that's why it unable to run the load. So that's why the brightness of this load will be decreases.